Today we're going to look at the HackerRank question, tree level order traversal. Given a pointer to the root of a binary tree, you need to print the level order traversal of this tree. In level order traversal, nodes are visited level by level from left to right. Complete the function level order and print the values in a single line separated by a space. So for example, in this first example here, we visit level by level, left to right. So it would be 1, 2, 5, then 3, 6, then 4. And we see what I just said is down here. And this is basically the same example as up there. And the constraints are, we have at least one node in the tree, up to 500. And you have to print the values, not return, print the values in a single line separated by a space. Okay, the runtime would this be O of n, where n is the number of nodes because we visit each node at least once, or just once. And this is a classic breadth first search problem. Breadth first search is a type of way to traverse the tree. Here we traverse it level by level, and that's the approach you're going to take. So for level order, what we want here is a breadth first search array, and initialize it with just the root. And we're going to use this array to keep track of all the nodes in each level that we're visiting. And we want a result array to store the value, or the info here of the nodes that we're visiting. So we're going to have a while loop here, while length BFS caps lock does not equal 0. That means while we still have nodes to visit in each level. So what we're going to do here is initialize new BFS. So new BFS basically is an array where we're going to store the values of the next level we're going to traverse in the next iteration of the while loop. So for each node in BFS, we're going to append the information of the node into this result array. And then what we're going to do after that is populate this new BFS array. So if for this node, if node.left does not equal none, new BFS append node.left. So if node.left has a value, has a node, it's not none, then we append that to new BFS, and we're gonna explore that node in the next iteration of this while loop. And we're gonna do the same thing for the right node. And finally, we're gonna assign the value of BFS to be new BFS. And this is going to be the new level of the tree we're going to iterate through. And as we can see here, if we finally reach 4, we'll see that node.left is none, node.right is none, new BFS will remain empty. Assign BFS to this empty array of new BFS, and it's going to be 0, so we're going to exit this while loop. So now, as the problem states, we have to print each node separated by space. So I'm just going to initialize here result string to be empty. Okay, and then for position and value in result, enumerate result. So this is a neat shorthand in Python to see both the index value and the actual value while traversing through the array. So if position equals 0, that means if we're looking at the first thing in this result array, we're just simply going to do self-string plus equals and string val. Else results plus equals space plus string val, because we want them to be space separated. So for the first value, don't have a space before it. For all other values, have a space before it. And finally, we're just going to print result string. Okay. This is classic breadth first search traversal of a tree. So let's see if this code compiles. Cool, it does. Let's try submitting. And the test cases pass. Okay. Thanks for watching.